Alright guys, welcome back to AtCoder Beginner Contest 202. Let me turn on the screen demonstration. So, let me play some music for myself. It won't be on the recording, but I don't know, I think it's fine. Okay, so it's a sponsored contest, as you can see, probably by some Japanese company, and if you live in Japan, then probably you know that you can apply there, and if you participate well, then you'll, I don't know, get considered in the first place, something like that. But we, of course, don't live in Japan, so we are here just to solve some problems. Yes, sure. It takes a bit more time than I would like it to. But, okay, we open this. Problem A, 3 dice. Takahashi has rolled 3 dice. They are shown numbers A, B, and C on the top faces. Find the sum of the numbers on the bottom faces. Okay. I believe that dice are made in such a way that the sum of dices which are on the opposite, sum of numbers which are on the opposite sides is 7, so we should be able to do it just like this. And you probably, like, you can simplify it, of course. Wait, what did I do? Should be 8, so. I'm pretty sure we could have submitted it without testing, but why not? Okay, okay, all is good. Here, this is the same as 21 minus A plus B plus C, but so okay, got accepted. Problem B. We're given a string S consisting of 0, 1, 6, 8, and 9 for some reason. I don't know what is the reason, but okay. Rotate the S 180 degrees and print the result. That makes sense. So these digits say like go to the reasonable locations. Like 1 goes to 1, 0 goes to 0, 6 so 1, 0, and 8 stay the same. Six goes to 9. 9 goes to 6. Yes, the last string is correct. The string before it is correct as well, and this string is also correct. So I don't think that we should double check it, like in our own test cases. It just looks fine. Yeah, got accepted. Actually, I should not have closed this one because I still want the submit page. Problem C made up. Given three sequences of lengths n each, a, b, and c, consisting of integers between 1 and n inclusive. How many pairs ij of integers between 1 and j, 1 n inclusive satisfy ai equals bcj? What the heck? Okay. Okay. That makes sense. It's again some implementation, but this time you have to like think a bit about it. Not much, but still. Or we just read the input. So clearly, because n is quite large, we cannot just do whatever we wanted to do. And what we will try to do is, like, we clearly want a to convert a to a frequency map, I'm pretty sure. So B is a bit more complicated. Like all indices in A have weight 1, but all indices in B have weight corresponding to array C. So I think that we also want to convert C to a frequency array. Frequency map, and then we convert B but with weights. So like FB at BI gets incremented by I think frequency map of I minus 1, I plus 1 of C. Okay, and then I probably want to say that our answer is computed like this. And you probably want to cast in between. So like the only trick is that a frequency map of B is weighted with weights from C. Or at least I think so. For 16.0, I am more or less confident that that's what, and this is what they wanted us to code. I don't know, why would you want, I hope no, okay, I did not make any stupid mistakes. Problem D, AAB, ABA, Okay. Once the strings of length a plus b consisting of a occurrences of a and b occurrences of b, find the string that comes case in the lexicographic order. Why? I don't exactly understand who finds these problems interesting, to be honest. 30 times 30. No, 30 times 30 is not what I should be calculating. Out of 60. That's the maximum number of strings that we can get, and it looks a bit long. I assume we could have noticed here. Oh, it was D2, okay. I actually don't like it, how we don't only have 2 test cases for this problem. I feel like there may be some complications. Damn, I should have saved it for D1. Okay, so how do we find case lexicographic string? We should know how many ways to continue we have from each position, which I can suggest doing as so. That's necessary. Oh, b plus 1, of course. So ways of 0, 0, there is only one string, which is an empty string. Okay, yeah, no. Wait, but okay. I also think that if you only have one kind of character, then you only have one way. Obviously not here, but here. So this corresponds like you only have letter A, so you still have only one string. Yeah, we are not doing anything smart here, we are computing binomial coefficients with dp. Ways of and the reason why we do it is because we want to check like whether we should put the current character or we should not. No, I think yes, okay, so. Okay, I suppose. They are indexed from 0, right? From 1, so we should. Like what I want to do is the following: if A else, obviously you want to just print B. So like minus B. If both A and B, then we have to choose. Otherwise we can just print letters and we actually know what to print. Like you can also print like string of and then AA but that's the same thing. But here we have to choose, and I think that what we choose is like so. If ways a minus 1b is greater than or equal to k, then I want to output a, decrement a by 1. And I don't want to do anything with k. Else, k should be decremented by this value. I want to print letter b and decrement b. Line 8, I did something wrong, of course. Oh, I just BAAB is the correct string, and here we get all B's and all A's. K may not fit into 32-bit. Yes, I can clearly see it from the samples. So the idea is we know how many ways we have to continue our string if now we take letter A. We would like to take, if we can take letter A and we'll still have enough strings to continue, then we'll take it because we want, because that's what part it falls into. Yeah, so I think that this is how it works. So it takes A, like A and B are that small, not because you have like any troubles with complexity, but because this value will just overflow for larger A and B's, even long integers will overflow. Okay, problem E. Count descendants. We have a rooted tree with n vertices numbered 1 through n. Vertex 1 is a root, and the parent of vertex I is the vertex pi. You are given q queries, the i's query given integers ui and ui. Find the number of vertices u that satisfy all of the following conditions. Vertex ui is in the shortest path from u to the root. Okay. There are exactly di edges in the shortest path from u to the root. So it's like we go to some place. I don't see why. Okay, I do see why we may have troubles, but okay, but it just means that we want to answer queries as we go and merge answers, no? Okay, whatever. Not that. Why I cannot simply... Yeah, okay. So like idea is simple, but we must follow some technical details for it not to kill you. For each vertex, we are interested in just finding like vertex u want to count paths in the tree, okay? Tree log something like this. Then they tell you, okay, buddy, vertex u is this guy. And now d is the distance. So we clearly want something in this subtree, right? Want this subtree. And then it give you the distance. To answer that query, you want to know the depth of that subtree, which is 1. You also want to, for every vertex, to store a map, like, oh, I have 2 children on depth 2, and I have 2 children on depth 1. So it will be like depth and then number of children. If they ask you about 3, then you say, okay, my depth is 1, and I want depth 3, so I should look for the key 2. And the only technical detail is how do you compute these maps quickly. Turns out if you have several children and you merge smaller to larger, then you always succeed. Your algorithm works in n-log time. It's not hard to prove because like you can bound how many times every element gets merged into other set. So every element, if it changes its set, then the size of the set that it is in increases at least by a factor of 2. So it cannot change its set more than log_n times. And there are only n elements, so you get your running time. That's just it. There's some strange for loops going on, but don't you worry. Pi is a parent of vertex I, so I assume that graph at Pi should get I, probably at Pi minus 1. At least it looks reasonable. We want to process the queries in the moment that we encounter their vertex. How to do it? Well, first of all, we want to read the number of queries, and then we have an ordered map of queries. Should I just... okay, I will just do it this way. UI, DI, so I want to store them here, and oh, I don't actually need this tuple. Of course, it's a vector of pairs. Pushback and placeback because it's a pair. So what do we in place? I believe that we in place depth and then index of the query. And index of the query we only need for our answers. Do we have to print them one by one or one by line? Okay, not big deal. Now we have a DFS. DFS returns pointer to answer, because to merge an ordered maps you have to return pointers, because if you return the whole thing, it usually means that you make a copy. and you cannot afford making a copy on every layer because of like trees which are very deep. And it takes an answer, it takes an integer vertex where we are currently, right? Am I right? I actually pass depths just to make sure. We call DFS of 0, 0. What do we do? What do we do? I'm a bit suspicious about that thing, but whatever. At depth 0 we always have one guy, which is our current vertex. And for every child, actually yes. For every child in of current vertex, we want to call. Oh, our tree is not binary? Is this a problem? No, I don't think so. I think that you write it like this. Probably like this, actually. Oh, actually, what did I do? What did I do? Frequency map in the current vertex, so of f and then DFS of child. DFS of child and then depths plus 1. Auto DII in queries of the current vertex. I believe I have to decrement this by 1. Vertex. And set I equals what? Equals frequency map. Oh, actually, wait a second. All of these guys have to be incremented by 1. All of these guys have to be incremented by 1. That's not cool. Oh, probably I don't have to do that strange thing. I just go like the depths, right? And then I don't have to increment the depths. Looks completely reasonable. Just set it to frequency map at depths. Turn F probably. F is a pointer, so we take it like this. I don't know. Looks reasonable. Actually, I haven't solved such problems in a while, so I mean, only one test for us. What is this? Okay, a lot of problems here. Line 3? Oh, I think that's like using... Yeah, type def is like less generic construction. 34 undefined ends, because this is ends, okay. A. Line 35. Oh, sure. What do you mean? Oh, I mistyped the letter. Three one zero zero looks reasonable. Like usually, if you have problems, then they are everywhere with such tasks. So because we know current depths, we just say that f is the number of nodes in the subtree with the depths respective to root of the entire tree and not the root of the subtree. It just works. And then yeah, I don't know. Should be fine. If it's not, then we can always debug, right? No, got accepted. Okay, problem F, integer convex hull. We're given endpoints on a plane. The coordinates of pi is xi, yi. We know that no 3 points lie on the same line for a subset S of P with at least 3 elements. Let us define the convex hull, okay? Convex hull means minimum area such that every point of S is within the circumference of the polygon, okay. Find the number modulo this guy of subsets such that the area of the convex hull is an integer. What the heck? There are 80 points, so we clearly cannot loop over all subsets. Is it true, actually? I think that we know, like, if coordinates are integer, are coordinates integer? It looks like there are. If the coordinates are integers, then I believe there's some math fact that says, like, Pick's theorem, I don't know. It says that area of any grid polynomial is always integer or half integer. And it depends on the parity of the number of boundary points. Fascinating. I'm just gonna take a quick look how many people are smart enough for this problem. Whoa. Whoa. Okay. That poses some questions about whether we are going to solve it or not. I think it has to do something with Pick's theorem. We kind of want the parity of the points on the boundary. And the points on the boundary we can compute it like how many points on every segment there are. Because if you think points on segments, there are not that many segments between given points, right? We only have like, I don't know, 80 points. So there are at most 640 segments between the points. Number of points on the segment, it's just some simple GCD computation. So it's also reasonably fast. And then it's not clear how do we count subsets. I assume that we cannot just add points one at a time, because that would look very strange. And we only care about convex holes. Because if we cared about polygons, right, then you can actually choose where to insert, and then probably you can count them. But with convex holes, it's not clear. I don't know, that's a problem where you have to think. And I'm not ready for this guy. Convex hole, huh? What are our possible ideas about convex hole? I honestly don't know. That's a bit beyond my abilities, I'm afraid. So I think it's a good time to review other problems. So simple implementation, you just have to know that, they actually tell you. So you don't have to know anything. Again, implementation, just don't forget to reverse the string. Basically, counting the number of pairs of equal values was always a frequency map. You loop over one guy and query frequency map for the second guy. But here, because of this index and frequency map is weighted, so some elements of B have many G's, such that Cj goes to corresponding index in B, and some have none. The only difference is that this time your second array has weighted elements. Here, a typical problem about case lexicographical smallest string, you want a way to quickly determine whether you can place the current character or not. Typically, it involves some quick way of computing the number of ways to complete the string if you place some character. Here, typical graph DP, like you understand that probably these queries can be answered in a DFS order because all you care about is the number of vertices at a given depth in some subtree. Always when you have subtrees, almost always when you have subtrees, DFS works. Then you only have to know about that smaller to larger heuristic, which is very similar to rank or size heuristic in DSU, where you basically say like, we'll merge smaller into larger and it will work in elegant time. That's the same thing. So a typical way to implement it in C++ is to return a pointer to an ordered map or to a map if you are on code forces and don't want to get hacked. Here I basically don't know, like it sounds like an involved problem where you have to sync, and I'm afraid that I would rather watch Monaco GP qualifying, which starts in like 20 minutes, so I'm gonna end this thing here. Bro, I guess that's the shortest screencast we have ever had, so, but at the same time, like solved 5 problems, I think it's more or less enough if it's not a rated contest, right? If it was rated, then I would invest a lot of time to think about it, but actually here I don't think that I want to. Maybe I will upsolve some problems. I also have some problems from Code Forces round that I participated in 2 days ago. I recorded it, but because I only solved 4 problems, I thought that, like, bro, nobody's gonna watch it because 4 problems were fairly easy. And even if you haven't solved them during the contest, then you probably could have upsolved them. And then problems D and E, only like 100 people solved each of them. So they were quite tricky. So that's it from me for today. I hope it was sort of educational. And see you with the next contest, which I believe will be LeetCode Weekly tomorrow in the morning for me, and probably today in the evening for you, if you live in US. Or also tomorrow somewhat in the morning if you live in India. So bye bye. See you next time.